Hi, welcome to this video. In this video I'm going to explain the JAL PCA9685 library for the PIC microcontroller. And as the title says, this library is programmed with the JAL programming language. So what will be the contents of this video? First, a short introduction about this device and its library that I created. Then the main functions and the extra functions provided by this JAL library. The hardware setup that I used for this demo, and of course a demonstration of the device and the library in action. And if you want to know more, you can find the references at the end of this video. So what about this device? So the PCA9685 is a 16-channel 12-bit pulse width modulation IC, which is normally used to control LEDs. So in fact was used to control the brightness of the LEDs, but you can also use it to control servos. The module uses an I2C interface for communication between the device and the microcontroller. And in this video I will show this PCA9685 library with a PIC microcontroller. And you will see a demo of the device in action. But you have to remember, there are also JAL libraries that can create PWM signals without the use of this device, but just using the peripherals of the PIC microcontroller itself. So what about this library? What it does, it translates function calls to I2C commands for the PCA9685. The library can support multiple devices if they are connected to the same I2C bus. And these are the following main features. Of course, it starts by initializing the I2C interface and the PCA9685. You can set the PWM frequency. You can set the PWM duty cycle per channel or for all channels at once. And you can do this in two ways. One by using a percentage, and the other way by setting the on time and off time and create in that way a PWM signal. You can set all channels or one channel on or off, and you can select different devices by changing the I2C address. But because we are using I2C, this library will include one of the JAL I2C libraries, and there you have the choice to use software I2C or hardware I2C. There are also some extra features, but you normally don't need them in, let's say, standard applications. So these are the extra features that are provided by the library. You can reset all the devices connected to the I2C bus. You can put the device in sleep to save power, and you can restart it again. If you want to, you can use an external clock rather than the internal clock which is provided by the IC. You can switch the output mode to totem polar open drain. You can invert the output signal. You can also change the output when an I2C acknowledge is received or only after an I2C command is received. You can set a so-called all call address, and you can also set 3 sub addresses. So the hardware that I use is quite standard. You can use any PIC microcontroller as long as it has, let's say, sufficient memory. And then on the right is a connection to the PCA9685 board. Of course it has the standard VCC and ground connections, it has the I2C clock and data, and there's an output enable pin that you can use. The V+ signal is meant for if you have servos connected to the board, you can power them separately. So the demonstration that you will see, what will be shown? I'm using a board with a PCA9685, but this board has resistors of 220 ohm on each of the outputs, which means that you can directly connect an LED. In the video you will see two servos which are controlled. One servo switches from left to right and then it goes back. Then the other servo switches from left to right, but in very small steps, and then it also will return to the starting position. There will also be two LEDs which are controlled, and we're changing the brightness of the LED. For this demo I used a PWM frequency of 100 Hz so that you can't see the LED flickering, but of course the camera will notice the flickering but the human eye will not. The default PWM frequency of the device is 200 Hz. And the cycle as mentioned above will be repeated in an endless loop. If you want to know more about JAL, you can visit the JAL download site, where you can find all the libraries and sample programs. If you have questions on how to use JAL, you can visit the JAL list Google group. If you want to report bugs in the JAL library or compiler, you can visit the JAL Lib Google group. And all the sources can be found on GitHub. See you next time, and thanks for watching.